So this is the command sudo user bin mysql. So this is mysql secure installation. Okay, so this is just to set up for your. So currently we do not have any password set up for us for root user. So enter current password for root. So it's none. So do I need to set the password? I will say yes. What is the password? My name MIMANT. Remove anonymous user, yes. Disallow root remote login, no. Remove the test databases and access to it, yes. Reload privileges, so I say yes. Now I can log in as mysql -user root -p password Himant, and I should be able to log in, right? Come out of it, and now give that thing over here. So my password of root user is Mimant. JDBC is 3306, it is running. So I can test the connection now. Yes, it's working. It's okay. And we already had created now Ranger database, Ranger user with password Ranger, and that's it. Now what are all the other things? So Ranger also we have. So similarly, Ranger audit also needs to be created like that. So Ranger audit user solar log. Currently audit to solar. Ranger audit solar URLs. If I off it, okay, so audit to HDFS. So currently we make it off. We need to understand its basic first, and then we will make it on, and then I will let you know what to do then. Okay, we just need to do whatever is bare minimum required in order to go with the installation for all these. Now what about Akimlo? So Akimlo password, I can keep my name Mimant. Okay, that is also done. Ambari metrics, you just need to provide the password Mimant. Then Ranger KMS, again it requires some password. Okay, so it says now Ranger KMS DB host, Ranger KMS DB name, SQL connector dot jar, JDBC connection, MySQL 33. DB host. So provide the host name where our Ranger KMS DB will be. So it would be host name would be hdpm2.cluster.com, and Ranger KMS DB name, Ranger KMS SQL connector jar. Local location of the DB connect client library. Please check the location of jar files. Okay. Driver class name, JDBC connection is string. Okay, it comes here, and Ranger KMS username. So again, we need to create this in MySQL. Okay, so I am going to MySQL, and I will say create database. This create user this identified by this, grant all on to this user, flush privileges, put Ranger KMS as the password. That's it. Do we have any test connection? Setup SQL. Okay, so database administrator DB, Ranger KMS root DB. Put root password is Mimant, just like we had done for user. KMS secret password, KMS master secret password, just put Mimant. SQL connector jar name. So we had already seen that, right? Where it is. Jar name would be MySQL connector java.jar. Let me put it here, SQL connector jar. I think everything is addressed now. Let me go to next. There are some warnings. High Tej container size is maximum. Okay, so we will fix all this later. Okay, so let's go with it because we need to understand the basics first. Okay, so we just need to have the installation ready. Deploy. Yes. Okay, so the installation of the remaining services are started. So basically, let's understand. Okay, so let's say you are having one 10 node cluster, right? I will say node 1, node 2, 3, 4, 5, 6, 7, 8, 9 and 10. These are 10 nodes in your cluster. I will mark them as, let's say this is my master 1, master 2. Most of the master services will be installed both on M1 and M2 on high availability. Rest, the other one are data nodes. I will say data node 1, 2, 3, 4, 5, 6, 7, 8. Now this is your cluster. This is the boundary of your cluster basically. Now you are setting somewhere external to this cluster. Okay, this is the boundary of your cluster, and let's say you are sitting somewhere here. This is your laptop. You might be in the VPN of this, okay, or you may access this cluster remotely somewhere. Okay, but ultimately, I mean, you need to be in such a way, so either you will use HTTP protocol or SSH, everything, anything, and try to get into this. Now what happens is basically this M1, M2 and the other data node, they are like the active part of your cluster. Those are hosting the services of the components of Hadoop. So just like name node, so I will say HDFS name node 1 over here. So I will say NN1, that is the first master name node, and this is name node 2, that is on the high availability of name node. So M1, M2 are holding or hosting this NN1 and NN2, that are the name nodes for HDFS, and other data nodes are hosting data nodes. Similarly, for yarn, resource manager will come on M1, M2, and the node manager, that is the slave part, may go on the other data node. Similarly, HBase master will come on M1 and M2, and the HBase region server will go on the data nodes. Okay, so this is like general tendency where the all master services may be deployed on M1 and M2 and the remaining slave services, or if they are like a service only kind of like client server architecture kind of thing, then we may deploy that also on data node 1 to data node 8. Okay, so I can install my high server 2 over here. Okay, or I can install my Uzi over here. Okay, it's perfectly all right. It depends on you. How do you plan the things? But best practice will be keep most of the masters with each other on master machines. Okay, and then their slave part should be identically installed on all the slave machines. Okay, but for few services like high server 2, high metastore, and more like those are not the master slave architecture. It's like client server architecture basically. That services you can decide on your end where to put them. Okay, but better like if you are having very good amount of RAM and CPU cores are available on master and master, because master and master 2, because since you are not going to use them for any analytical purpose, right? So most of the resources must be free. because name node 1, name node 2, that is on master, they you can give them like around 10 GB of RAM. That is more than enough, because if we already have seen that if 1 GB RAM can have 1 million of blocks, and 1 million one block is of 128 MB, it means that even for few terabytes of data, that 1 GB is more than sufficient to hold the metadata information for name node. Okay, so most of the times, even if they are client server architecture and those service needs to be installed, have them master and master 2 on, right? and don't load data nodes much with some different services. Those are not the part of slave services. Okay, uh, and allow them just to hold the data. Okay, and then allow them to run the tasks that will analyze the data. Okay, so that is the general tendency we can think of. Now these are 10 nodes in our cluster. We can add one more node over here. I will say edge node 1 and edge node 2. Okay, so I will say this is my edge node 1 and this is my edge node 2. Depending on the cluster size, you may have more edge nodes also, or like for 10, one single edge node will be enough. Now then, these edge nodes basically will give you kind of, this edge node also can be managed by Ambari or Cloudera manager, and it should be like that. So whenever you install edge node, you just give one more node. So I will show you that how to install, how to add the nodes in your existing cluster. Okay, so you can add a node to your cluster, but don't install any services over there. Just install only clients. Okay, so let's say this 10 node cluster I built, and then I added 2 more nodes to it and name them as edge node 1 and edge node 2. Okay, it could be only edge node 1 only. Okay, or single edge node could be also there, or it could be 3 or 4 depending on the size of cluster and the number of users you are handling. Those will access this cluster. Okay, so on this edge node and wide node 1, I will just install clients of HDFS, or sorry, client of Hadoop, or client of MapReduce, client of HBase, client of Hive, client of Uzi, that can just access those services. I mean, the clients only will be there. So suppose from your laptop you do have the IP address of this edge node 1 and edge node 2. So you can either connect to this or you can connect to this. Okay, and when you come to edge node, okay, so edge node, let's say your user, let's say I will say this is user 1. Okay, this is user 1 who is accessing the things. So you can locally create the user 1 user on edge node 1 and edge node 2 and have assigned it a password. So whenever this through laptop 1, if user connects to edge node 1, just like through SSH, he will go there, he will put his password, and then he will log into edge node. As soon as he gets into edge node, all the clients will be available to him. Like he can run then Hive, HDFS, Hadoop. Okay, all the commands all the commands related to the Hadoop components in order to access them. All those clients will already be there on edge node 1 and edge node 2. That's why they are built. Edge nodes will always have or only have the clients. They do not have any active part or active service installed on them from Hadoop. Okay, so edge node will never have data node, edge node will never have name node, edge node will never have any HBase related components to be installed. Only the clients. Okay, you know that whenever we add any service, it will also give an option of adding client where you want the client to be installed. Okay, so mostly for all of these services we selected our master. In the case of HDP, we selected every client to be installed on HDP M2. Okay, but in actual production you may have 1 or 2 or 3 edge nodes, and there you need to have all the clients. Okay, you also can have the clients installed on every machine, no issues, but then again you need to route all the requests to this cluster through edge node only. This is your cluster, and only through edge node these are getting connected. Okay, your user does not have any direct access to any of these nodes internally. So suppose if this user wants to connect to, let's say, this data node, it cannot be. Okay, so this is not possible directly. So on edge node, what you can do is basically you can get some data on edge node and then force it to be written into your HDFS directory system. So this is HDFS, right? So I will say this would be HDFS internally. Okay, and this edge node and edge node this is not the part of your HDFS file system, because no data node is installed on edge node 1 and edge node 2. So suppose if you want to write the data into cluster, what you will do, let's say you have one FTP server here from where you want to pull the data and then write it into HDFS. So what you will do is basically you will first connect to edge node from your laptop. On edge node you will try to pull the data from this FTP and put it into edge node first. So you will get some data over here. Okay, let's say this is the file that I got from FTP, and its name is file.txt, as we have seen somewhere in the naming convention. I mean, not naming convention really, but whatever file it is. And then you can use hadoop command in order to force this particular data to be written into hadoop distributed files. That is how generally it works. Okay, directly don't get the data into FTP into HDFS. Most of the times when you load the data, it would be mostly edge node, and from edge node you can copy it into HDFS. Okay, and once the data gets into HDFS, you can further write some code in Java, Scala, or some Hive queries, and the whole Hive infrastructure again. So I will say public Hive infrastructure also running under this boundary of orange. Now you can access the Hive client through edge node and then write your query and fire that query that will operate on the data of HDFS stored in your cluster now. Okay, so on this edge node basically you can then have all the kind of security installed, user creations, some permissions that you can give, some permissions you just don't give, you restrict some of the accesses to the things. Okay, so now the good thing about this design is that basically you just need to focus mostly on edge nodes, because from there only the users can get into your cluster. There is no other way, because even the laptop one user does not know what is the IP address of name node 1 and name node 2. Okay, until unless it does not go and then scan the hosts file of edge node 1 and edge 2, because on the host file of edge node 1 and edge node 2 should have the addresses of all these internal Hadoop nodes basically. Okay, so you disallow him to watch even see the hosts file of edge node and edge node 2, so that he will never know that how it can connect. But then whenever he start running HDFS, yes, he can access it, Hadoop fs Hadoop fs -ls, and then so he can go into a Hadoop distributed file system and then can access it. Okay, so we will create this model. Okay, so we have now our 3-node cluster installed. What we can do is we can add one more node and make it a edge node for our 3-node cluster, and we will access edge node, and through that only we will run all Hadoop things. Okay, that's what actually we can do now. So this is the concept of edge node. Okay, it will just isolate. Okay, this is mostly for isolation and for better security, for better management of your Hadoop cluster, because the number of nodes in this orange boundary basically may run in few hundred nodes, 200, 500 nodes also. So you need not to do, and that number of nodes can increase and decrease day by day depending on your workloads, right? Suppose if you deployed this infrastructure on cloud, what will happen is basically on cloud you can increment the number of nodes on the fly whenever it is required. Okay, or you can bring them down, okay, once your workload is finished. Okay, because why to pay money for those nodes which you are not using at all? Okay, so you can increase and decrease the number of nodes on the fly in few hours. Like half an hour you can add 10 nodes and have them the active part of your Hadoop cluster. Once the analytics will be done, you just remove those 10 nodes and you are good. So there are automated scripts that will automatically create a Hadoop cluster of 500 nodes, load the data into it, do the analytical things, extract the data of analysis, put it in some remote server or on some reporting tool, and once the reporting is done, they will just kill that Hadoop cluster of 500 nodes, and then on the cloud you stop paying money for that. Okay, so this kind of very automated. Currently we are putting very hard effort of building these Hadoop cluster, right? But then there are more easier ways of doing this. Okay, This Ambari server, what we are using in order to build our HDP cluster, is having some REST-based APIs. Okay, you can go through the documentation of REST-based API, and then you can automate the creation of this cluster on its own. You just need to fire that script, and you will be ready with 10 node cluster running on the cloud. It's so easy. Okay, but then you need to go to that level. Basically, if I say I will say let's Ambari APIs, REST APIs. So you just need to install Ambari, and Ambari APIs, you need to call it Ambari APIs in a script, and everything will be built automatically. So Ambari views REST API overview. Let's suppose I want to run some I will show you some commands of this. So that's actually called curl. Okay, so curl is a command. I will say curl is a command through which you can call some REST based APIs of any Java utility, and it will give response directly on here. So if you do curl help, then it will tell you that what else you can do with. There are a lot of options. Okay, again it's a Linux based utility in order to call. So you can say curl and just do www.google.com. What it will do, this is the response from google.com for this curl, right? And you will get a lot of things around it. Now if you open the google.com on your browser, you will find that so this is like Google, right? Go here on this, and more tools, development tools, and this is the element basically. So when I say www.google.com, again it gets me some, this is the data actually, that how it looks like when it comes. Okay, you can have sources, you can have further more things, but this is basically the response from it. Okay, and the similar thing you're getting here. So curl will actually give you the way, because ultimately whatever you do here is all REST based APIs. And what is REST? REST is a like kind of framework. So this Google website is running on one server, right? The server is maybe somewhere hosted in US or somewhere else, and we are hitting it. Okay, so this particular address is being translated to the IP address of google.com. Okay, and when it hits that server, we need to get the response. So there is one REST API being called when you do this, and it will give the response back. Now if you want to search something, so I will say AWS, this is a search. So if you see this HTTP, this is the overall things built. Okay, so it is like a response from it. Okay, if I do the same thing over here, curl, so I will get some response. And here if you see, okay, there is no response at all. Did it give us curl? Okay, currently the document has moved, so this is not the valid URL maybe. Okay, but then when you search AWS, it actually builds this thing over here. So all the calls are REST based. Now whenever any component gets built, right, for Hadoop, it also comes with its REST APIs if it is like kind of being called from the other thing. So I will say Ambari REST API example. So basically we'll get that how to know the name of the cluster that we have put. Popular Ambari REST API command, so we can just call on it. I'm just closing it now. And so this is curl Ambari user, Ambari password, then requested as Ambari x get. So now there is a complete document that you can just go through it, but let's say delete a host component. This is how delete a component on a host, delete a host. So you can delete the host directly just by calling this thing and pass which host you want to delete from your cluster. You can add like that. Okay, so this is the way of dealing with the curl Ambari REST APIs. Let me just search how to get the name of okay, so if you run this command curl, okay, and then the user would be admin, and this is we need to provide the requested by Ambari. -x is like we are providing with which, so get, put, post, delete, this kind of curl you can say things that you can do. And this is the website HTTP HDM. So this is running on 8080 API 1 clusters. So if you run this, you will get the cluster name. Okay, so it will tell you what is the name of cluster, what is the version, okay, and this is the reference that we are using in order to get this information. Now suppose if you get this, you can just in a script you can look for it, scan for it, and then you will get your name of the cluster. Simple. You can, so that is for get. Now if you do post, you may need to change you can change the name of the cluster also, right? So there is a complete documentation built behind it. Okay, so whatever you do, so this is just like the for your information purpose. I mean, if you using get, it means that you are just reading the curl responses, and you are just reading the overall configuration for Ambari and Hadoop through Ambari REST APIs for Hadoop. Similar on the other way, you can do get, delete, post, and then put. So REST API like put, get, post. These are like all REST APIs. You can say verbs, or basically these are some keywords basically that you will deal with while doing the REST API calls. Now we can create a whole script. Okay, currently what we have done is we have installed Ambari, and then we are doing this whole thing manually, right? What we can do is we can create a whole complete automated script using all this REST based APIs. Okay, it may be some long maybe, and you just call it after installing Ambari, then call the script, and all the REST APIs of Ambari will be called, and your cluster will be ready and running at the back. Okay, I will prepare a video on that, okay, to create the cluster and install some basic services. Okay, that will definitely help you out. Now there are furthermore things that you will do this REST APIs, okay, and this is the, I think, not document exactly, but it will tell you that what you can do. So till here you can just get them. Then if you want to get what are all the services of now running on your thing, I can just do cluster name should be this new cluster. maybe some installation is going on. But then no, you can just get more information like this. So the overall, the overall look of your Hadoop cluster is similar to this. Okay, where H1 and H2 play. Now there could be multiple users. So here we are trying to create the user directly on Edge node, but that is not the case when you do have the user database managed by your Active Directory. Okay, so you know that whenever you work in any company, basically whenever you are new joinee, your user ID will be created, and that user ID will be used everywhere throughout the company. Okay, the company offices are in multiple places. So whole that user database is managed through Active Directory. Okay, Active Directory. So you just need to create the user ID on only one place, and that user ID will be used for all the infrastructure in your office. Okay, similarly here we do have one Active Directory, Windows Active Directory running as a server. When the new user comes, he will get his user ID created directly on that Active Directory, and then Active Directory will either sync that user to other infrastructure, all the services, or the services may refer the Active Directory in order to validate the user whether he is the proper user or not. So Active Directory will come with the Active Directory management as well as the Kerberos authentication. Okay, so we will see that. We need to install one 2016 Microsoft server and Active Directory server. We will create some users over there, then we will integrate that with this Hadoop infrastructure, and we will have all the user database to be created on one Active Directory, and we can be used. So all those users can then be easily used to get to execute the services on Hadoop. Okay, so a lot more things. So this is the conceptual behind what is the Edge node. Okay, why Edge node is getting used, and you definitely hear in the production terminologies where you find 10 or more than 10 nodes, basically you definitely find one or two more Edge nodes associated with it. Any questions around it?